Hi, my name's Ben, and today I want to talk to you about the importance of the beam spot size on 1D displacement lasers. Let's say here you have a laser, and a 1D displacement laser emits a beam and it projects out to a point and hits it on a part, and then it's reflected back to a receiving element. The point at which the laser beam hits the part and it's reflected back, that's the beam spot. That's typically specified in the manufacturer's information in size, and its size is typically listed as microns. Most of the smaller beam spots that you'll see in a 1D displacement laser are along the range of 20 microns, so they're really pretty small. One of the things that people run into quite often as they try to transition from mechanical measurement systems into laser-based systems is they have a surface finish on a part. Typically machined parts have, when they're under magnification, have extremely high profiles of peaks and valleys. This is quantified and qualified in an area known as surface finish parameters and surface finish measurement. If you look at parameters like RZ, which is the distance from peak to valley, typically if you're in anything other than really super smooth or polished surfaces, you're going to have a pretty significant distance from those peaks to valleys. Typically, it can be a thousandth of an inch or more. A typical indicator that's on a, and the foot on an indicator or tip doesn't see those valleys. And so an indicator, whether it's Mitutoyo, Starrett, whomever, a digital type unit, is always going to see those peaks. A laser, on the other hand, it's going to traverse across those peaks, and it's going to see the valleys along with the peaks, and it will reflect those differences. And while oftentimes the laser is much more accurate, it's picking up those differences, and it can be disconcerting to customers because they're not used to seeing that variation. It's really a reflection of the laser's superiority over this type of indication and reading.